They want us to use Huffman coding to encode the symbols given the frequencies, and then figure out how many bits on average we will need to use in order to encode any letter. Right, so the first thing we want to do is start to make some trees. So let's go ahead and do that, and we can just make a tree for each of these single letters first. So we're going to have an A, B, C, D, E, F, and G. And then above these, let's put their frequencies. So we have 0.1, 0.25, 0.05, 0.15, 0.3, 0.07, and then 0.08. So these are going to be the frequencies that we're given. Now, what we want to do is identify what is the two smallest frequencies that we have. Well, in this case, that's going to be 0.05 with C and 0.07 with F. Now, what the Huffman coding tells us to do is put the larger of these to the left, like this, and then we create a tree for these. So F is going to be 0 and C is going to be 1. Then we would want to add these frequencies together, so that's going to be 0.12. So now let's go ahead and get rid of these old frequencies, and then we can go ahead and move these two letters up. So now what we could do at this point is just go ahead and throw that back in line, and then compare all of these like we did at the start. So we have 0.1, 0.8, and 0.12. So it looks like that's going to be 0.08 and 0.1. So these are going to be the two that we're comparing. So we want to put our more frequent one to the left, our less frequent one to the right. So looks like 0.1 is already there for A, and then 0.08 is to the right. So that looks good. So that means A is 0 and 1 is going to be G. So again, let's go ahead and erase these frequencies right here and scoot our letters up a little bit. All right. And so A and G. So A was 0.1 and G was 0.8. So this should be 0.18. Right. Now we're going to throw this back in line. So we have 0.25, 0.15. So it looks like it's going to be 0.15 and then 0.12. So we're going to have these two. So again, remember, we want the more frequent to the left, which we have here, and the less frequent to the right, which we have. So that means D is going to be 1, and then this tree over here, or I'm sorry, D is going to be 0, and then this tree over here is going to be 1. So then we would add those two frequencies up, which is going to be 0.27. And then let's go ahead and get rid of those old frequencies. And then we can go ahead and scoot up D. And then we can also scoot this tree up over here. And then again, we're going to throw this back in line with the other one. So I'll just throw this over here on the left. And now we need to compare these. Well, that looks like we would have 0.25 and 0.18. So now we create a new tree for these pair. So that would be B on the left since it's more frequent, and then the AG tree to the right since it's only 0.8. Right, so we have 0, 1. and then we would add these up, and this is going to be 0.43 for the frequency. Then we can go ahead and erase these and then move these letters up, and then move this tree over here up. Okay. And then we're going to compare these three. And so that would be 0.3 for E, and then 0.27 for this tree that we have over here. And then I'm just going to move this to the right, and I'll just scoot this up. All right, so we make a tree here. So again, more frequent to the left, less frequent to the right. So this is going to be 0, 1, add those probabilities up, and that's going to give us 0.57. So let's get rid of our old frequencies, and then we can scoot these trees up. All right, so we have this. Then we need to compare these two, and well, 0.57 is larger than 0.43, so that means we would go ahead and keep this on the left and keep that on the right. And then if we add those frequencies up, that should just give us 1. So let's just go ahead and get rid of those frequencies. All right, so that tree that we should have should look something like this here. So 0 and then 1. All right. Actually, we can scoot this up a little bit more, just so it looks a little bit more even. All right, so we have this now. So this is going to be our tree for this coding. So now let's go ahead and actually write everything out. So to get E, so that's going to be 0, 0. So E is 0, 0. Now for D, that's 0, 1, 0. 0, 1, 0. For F, so we go 0, 1, 1, 0. So 0, 1, 1, 0. And then for C, well, the only difference between F and C is it's just 1s at the end, so it would be 0, 1, 1, 1. All right, so we're done with the left side of this tree. Now we go over to the right side. So for B, that's going to be 1, 0. Then for A, that's going to be 1, 1, 0. And then for G, the only difference between that and A is that last one being a 1. So it would be 1, 1, 1. All right, so now this is going to be our coding here. Now let's go ahead and figure out average number of bits we would need for each of these. So let's put the bits here. So E has 2 bits, D has 3, F has 3, C has 3, B has 2, A has 3, and then G has 3. And then here we could put our frequencies. So A was 0.1, B is 0.25, C is 0.05, D is 0.15, E is 0.3, F is 0.07, and then G is 0.08. Right. And now we can go ahead and multiply the bits in the frequency and then add all that up. So we want to multiply going across here. So that would give 0.6 and then 0.45, 0.21, 0.15, 0.5, 0.3, and then 0.24. And then lastly, we're going to add all these up. And if we add all that up, it looks like we get, looks like 2.45. So this here should be the average bits to code each of these letters here. And one thing that can kind of tell us that we did this right is that notice how our most frequent letters here have 2 bits while all of our other frequencies have 3. So as long as the most frequent ones have a lower bit count, then it's normally a good way of saying that we did it right. Oh, and then over here we can just say that this is our coding.